Hi, my name is Johannes Gilg from Technical University of Munich, and today I'll give a quick overview of our research where we take a closer look at object detectors and we ask ourselves, do we still need non-maximum suppression? Accurate confidence estimates and implicit duplication modeling with IOU-aware calibration. But why would we want to get rid of non-maximum suppression, you might ask? Well, the normal non-maximum suppression introduces arbitrary cutoffs, where a little difference in overlap means the difference between a drop detection or a cap detection just as is. For the soft non-maximum suppression, the discounts can seem quite arbitrary. How much is the confidence discounted for the same overlap? It varies. But more importantly, both of the non-maximum approaches lead to miscalibration in object detectors. Instead of the classical approach, where we first perform non-maximum suppression and then calibration, where the non-maximum suppression actually hurts the calibration performance, we want to jointly model the problem of deduplication and confidence calibration in one approach. For this, the confidence of a detection needs to accurately reflect the probability that it's a true detection, given that it's a duplicate, times the probability that it's a duplicate given what we know about the detection, which is its confidence and its overlap with other detection, plus the probability that it's a true detection given that it's not a duplicate, times the probability that it's not a duplicate given what we know about it. These terms are quite hard to estimate, but we can simplify it into just the probability that it's a true detection given what we know about it, so its confidence and overlap with other detections. This is actually a multivariate calibration problem. There's just one issue remaining. This overlap with all the other detections is a variable length vector, and we need to simplify that if we want to calibrate it. To capture the overlap of a single detection with other more confident detections, we try different summary statistics and combinations thereof. The minimum Gerhard distance captures this effect well in a single variable. For the calibration function, we use the multivariate conditional beta calibration function, which offers good overall performance. Let's have a look at some numbers for the faster RCNN detector. Now, if we only do calibration and no non-maximum suppression, we have pretty good calibration performance, but poor MAP, so overall detection performance due to all the duplicates. The best non-maximum suppression for this detector is the soft non-maximum suppression. It offers very good performance, but we can see if we first do the non-maximum suppression and calibrate later, the calibration performance suffers. Now, our conditional beta calibration offers the same performance, but way better calibration performance. When we apply our approach to a range of object detectors and compare it with the classical approach of hyperparameter tuned non-maximum suppression with calibration afterwards, we see that we can match the performance quite well and have way better calibration performance. Thanks for your attention. So do we still need non-maximum suppression? No, we can just use IOU-aware calibration.